Hi there, I'm Mr. Zan. I'm going to go through a couple equations right now and we're going to balance them. Now, in your reading, whoa, I need to zoom in there. Zoom in, please. Zoom. Zoom. All right, there we go. And move around. Okay, now in your reading, you've got a couple rules. One is to take a look at the most complicated molecule and start with that first, and then go through each atom on each side of the reaction arrow and make sure that there's the same amount of elements on one side as there are on the other side. So we're going to do that, and we're going to walk through each and every one of these little small equations right here, and hopefully we'll run into some difficult ones. So let's start off with this one. We've got H2 plus Cl2 goes to HCl. That's not an I, that's an L. That's chlorine. Okay. So I'm going to I could choose H2, but I'm going to start with Cl2. And I notice that there's two of them right there, and there are no other chlorines on this side of the reaction, and there's one over here. So what I want to do is I want to multiply this entire thing by a coefficient 2. That means that there'll now be two of these H's on this side and two of the Cl's on this side, the two of the chlorines on this side. So what that does is that makes me confident now that the Cl, or the chlorine, is balanced on both sides. Now I take a look at the H2 and I see, all right, there are two H's on this side, and there are now 2 times 1 right here. So that means there's 2 on this side. So both of sides of my equation are now balanced for this first question. So what this really means that there is, like, you can think of this as like an invisible 1 multiplied by this and an invisible 1 multiplied by that. The coefficients here, you can multiply a whole molecule by a coefficient. That means that this whole molecule is just basically doubled. Instead of writing HCl plus HCl, we just write 2HCl. So that 2 means that there's 2 of these HCl molecules. So 2 hydrochloric acid molecules. Okay, let's go on to this second equation over here. I don't know which one's the most complicated. I'm going to say the CH4 is the most complicated, all right? Okay, so I look at the C first. I see that there's one C. Okay, there's one C there, no other C's on this side. Great. What about this side? One C over here. That's it. So they're both balanced. So I'm just going to make a little check right there. Okay, there's 4 H's on this molecule right here, and there's another 2 H's right here. So overall there's 6 H's on this side, and there are only 2 on this side. So I'm going to multiply this by 3, so that way I can get 6 H's over here, and that will make all of my H's on this side happy. Okay, now I've got 1 O on this side and 1 O on that side. It's great. So it's full balanced equation. CH4 plus H2O yields CO plus 3 H2s. All right, on to the next. This one looks like the most complicated in the next equation, so I'm going to start with that. Fe3O4. So there are 3 irons, which is Fe. And over here, there's just 1. So I'm going to multiply this by 3. That will get me my irons all balanced out. Now we've got 4 O's right here and no other O's on this side. So I'm going to multiply this entire thing by 4. 4 COs. That will get me my O's all balanced out. Right. Now I look at my C, my carbon. My carbon, there's 1 on this side and there are 4 on this side. So I need to multiply this by 4 to get my carbons all good. So all the elements now are balanced. These are really easy. Okay, on to the next. We've got no plus O2 equals no 2. Okay, so I'm going to start off with NO. NO. There's 1 N here, and there's 1 N on the other side, so they're balanced. And there's 3 O's on this side, and there's 2 O's on this side. So what do? We've got 3 on this side and 2 on this side. So if I could multiply what am I going to do here, huh? How would I solve this? Think about it yourself. What would you do to solve this? Let's see. So I want to make sure that, so there's 3 O's on this side, and there were 2 O's on this side. So if I could multiply this entire thing by 1.5, yeah, maybe. Let's try that. 1.5. I'm just trying this out, see what this goes. I've never done this one before, so we'll see where it leads. 1.5. That will get us, that'll give us how many on this side? That'll give us 3 on this side, 3 O's on this side. But on this side, it'll give us 3 as well, but now our ends are not balanced. So this is not going to work. Okay, that's not going to work. So what are we going to do? Well, I suppose what we could do is multiply this by 2 and see if that makes our lives better. I would do that just so we can have more to work with over here, because it looks like we have O2 right here, and that might give us something to work with, because this O2 is by itself, so we can just modify the oxygens by itself and not worry with the N as well. So let's try that. Let's multiply this by 2. All right. So if we multiply this by 2, that gives us 4 O's over here. And on this side, well, on this side, we still have 3 O's. Okay, so this is starting to look a little bit tricky. All right, so let's start. Let's see, okay, we've got that 2 over here, so that means there's 4 oxygens and there's 2 nitrogens. So let's go back to our nitrogen and take a look at that. There's 2 over here and there's just 1 over here. So if I multiply this by 2 now, that means that the nitrogens will be, again, balanced. And we have now 1, 2 oxygens, and we've got 4 oxygens. And we've got over here, now we've got 4 oxygens, because 2 times this O2 is also 4. So now we've got all of our O's balanced. So that one was a little trickier than I anticipated. It was just a little bit of a workaround. I put a 2 there just to try to get us more oxygens to work with, and it ended up working out. Okay, let's go on to the next one. Sometimes these are a little bit of a trial and error, but you get a little intuition after you work with them for a while. Okay, so I'm going to start off with this big molecule on this side. All right, so NaNO3. Sodium is Na. So there's 1 Na here, and there's 1 Na on that side, so that is balanced. Great. There's 1 N right here, and there's 1 N over there. Also great. Now there are 3 O's over here, and there are 4 O's over there. This is not so great. Oh, why did I do that? I shouldn't have done that. I'll just erase those checks. Okay. So what do? Do I panic? Do I run away? No. What I do now is I multiply this entire thing I just double it to see if doubling it will help us at all. Because what I'm thinking is if I double this over here, I can easily double this guy over here. And then I've got extra oxygen over here to try to work with. So I'm just going to double this. So if I double this, that means I'm going to double this. So that makes our sodiums okay, because now there are 2 sodiums, there are 2 nitrogens. Now let's take a look at our oxygens. I'll just write down a number now because it's getting a little bit high. So we've got 2 times 3, which is 6 oxygens on this side. And now we've got 4 oxygens on this side with this molecule being doubled. And another 2 right there. So that's 6. So that means it's balanced. Yay! Right. Next problem. NH3 plus O2 and this over here. Right. So we can start wherever we like. I'm going to start off with the NH3. Okay, so there is 1 N over here, and there's 2 N's over there. So I'm going to multiply this sucker by 2. That'll get us equal amounts of nitrogen on both sides. Now there are 6 hydrogens on this side. There's only 2 on this side. So I'm going to multiply this by 3 to get 6 and 6. Okay, now our oxygens. There's 2 oxygens over here, and there are 3 oxygens over here. So what do I do? This is a tough one. This is one where there's clearly more on this side. I'm not going to double anything. I'm going to do something kind of crazy. And this happens every once in a while. And the reason I think this is going to work is because you've got these oxygen all by itself over here. So if there are 3 oxygens on this side and just 2 on this side, I'm going to multiply this by just temporarily by 1.5. Okay, if I do that and nothing else is affected and everything is balanced right now, it's kind of a little cheat. Okay, so if I multiply this by 1.5, that means that there are now 3 oxygens on this side, and there are still 3 oxygens on that side, and everything is balanced. Isn't that great? It's great, except for they get this silly 0.5 here. So to get rid of the silly 0.5, you multiply everything by 2. So if you multiply everything by 2, so this is an entire equation, by 2, then you'll be balanced. Okay, so I'll do that. So this will now be 4. That'll be, if you multiply this by 2, it'll be 3. This will be 2. And this will be 6. And you can double check. All these numbers do match up. So there's 4 nitrogens on both sides. There are now 4 times 3 is 12. So there's 12 hydrogens there, and there are 12 hydrogens there. There are 6 oxygens here, and there are 6 oxygens there. So this is great. So this means that this is now balanced. I'm happy that we got a somewhat difficult one. Okay, I think we've gone through enough of these problems, but yeah, I'm going to stop right there. So you can figure out these other 2 on your own if you like. If you have any questions with them, please let me know. And you've got lots of problems to practice with and lots of like games to play as well. So keep practicing these. It gets easier once you start to kind of see some of the problems that arise and some of the tricks you can kind of employ to figure them out. Okay, that's it for me.